So it's amazing, but 1.1 has gone into 3 videos. So this is part 3 of that, and that's the last thing that is in 1.1. 1.2 is actually really short, and so you'll see. But the last thing to talk about is symmetry. And so I'm trying to keep the videos at around 30 minutes or under each, and I've failed at the 2 videos I've made today so far. But I definitely will be able to do it on this one and work on it in the future. Anyway, so let's get to it, the symmetry. And so they talk about in your book, and later they'll talk about more symmetry, but in 1.1 they just talk about 3 symmetries. They talk about symmetric with respect to the y-axis. And so this is y-axis symmetry. So you can see here's the y-axis, and you can see the symmetric on, it looks the same on either side. And they make this note that something is symmetric with respect to the y-axis if every time a point AB is on the graph, that the corresponding point negative AB is also on the graph. And they kind of show that here. Here's AB, and then over here would be negative AB. And of course that could go with any signs. A could be negative, and then you would be over here, but then the reflection would be over here. And then the other symmetry that they talk about is x-axis symmetry. So here this one's symmetric with respect to the x-axis, and you can see that if AB, the ordered pair AB is on the graph, then the ordered pair A comma negative B is on the graph. And then the other kind of symmetry, the third kind that they talk about, is origin symmetry. And if AB is on the graph, then negative A, negative B is on the graph. And then they talk about some tests in your book. To test if a function or if a has y-axis symmetry, right? They say replace x with negative x in the equation. And if the equation can be simplified to be the same equation you started with, then the graph of the equation has y-axis symmetry. And with function notation, because this is a function, right? Remember the vertical line test only hits it once. This would be the test, and they call it an even function when it has y-axis symmetry. And that's if f at negative x is equal to f at x, then it's an even function and it has y-axis symmetry. A test for whether or not it has x-axis symmetry is to replace y with negative y, and the same standard, simplify the equation, and if you can simplify it to what you started with, then it has x-axis symmetry. You notice that they don't have anything with it being a function, because vertical line test, it's not a function. And so, but it still could have, something can still have x-axis symmetry. And then things that have origin symmetry can be called odd functions. You're going to replace x with negative x and y with negative y. And if you can simplify it to be the same thing you started with, then it has origin symmetry. Another test with function notations is if f at negative x is equal to negative of f of x, then it's an odd function. And so we're going to look at this problem, problem 74, and they're asking us, is it odd, even, or neither? And neither doesn't mean that it has x-axis symmetry. Neither means it has no symmetry. And so here I've got things that have symmetry, but I could have had something, that's, all wild and doesn't have symmetry. Maybe I'll make it go really wild and not have any symmetry. There's a down arrow, whatever have you. So it doesn't look the same through the y-axis on each side. It doesn't look the same through the x-axis on each side. And I tried to make it look not like it had any origin symmetry or anything. So anyway, so it could, and that would be neither. It doesn't have any symmetry. So, and so I have given people in the past a picture and asked what, a graph of something, and asked what kind of symmetry does it have? Is it odd? Is it even? Is it neither? Or does it have x-axis symmetry, and people have said, well, you didn't give me the function so that I could do one of these tests. And well, I wasn't hoping, I mean, I'm looking out my window and I can see like 15 hummingbirds, and they're all like, I wonder what's making them so crazy today. I mean, they are absolutely, I'm going to have to make some sugar water for them. Anyway, it's so fun to watch them. Get a hummingbird feeder. I totally recommend it. Anyway, long story short, you can look at the graph and you can tell, you know, and so if I asked you, if I gave you that graph, you'd have to say neither. If I gave you this graph, you could answer the question. Okay, so anyway, but you don't have to graph it. So I don't have to graph this one to answer the question. And so what I can do is I can look at, well, what does f at negative x look like? And so remember our trick? Where I see x, I'm going to put parentheses, squared. Where I see x, I'm going to put parentheses raised to the fourth, plus 1, right? And I'm going to go and I'm going to fill in what they're telling me to fill in here, which is negative x. So when I put in here negative x and negative x. And then this one's quite lovely, right? Because negative x squared, that's negative x times negative x, and a negative times a negative is a positive. So that's x times x, right? Positive x squared. So this is x squared, and same with negative x to the fourth, negative x times negative x times negative x times negative x is x to the fourth plus 1. And so you can see that that is exactly f at x. So f at negative x is exactly equal to f at x, and that was an even function. So they asked us, is it even? And then just because I've only into this crazy little video, 7 minutes, you know, so this is bonus footage. I'll put this as an example and bonus footage. If I had this, x to the third, had this been my function, and I asked you the same question, so I just changed one thing about it, right? You could do your test. So this would be right to the third. I like to put, I say blank to the third, but it's parentheses. You replace x with parentheses. Replace the x with parentheses, and now go and substitute in negative x. Go and substitute in negative x. So for the same thought, negative x times negative x times negative x is a negative times a negative times a negative is a negative, right? And x times x times x is x to the third. So this is negative x to the third divided by, and that's going to be x to the fourth plus 1. And just like the last problem that we did in part 2, this negative times the x to the third, there, you could write that negative out in front of the fraction if you like. In my algebra class, we always look at this, that negative a over b is exactly the same as negative of a over b, which is exactly the same as a over negative b. All of those are equivalent to one another, and so I'm actually applying that right now, and I only have that negative going on one thing, a monomial there. If I had a negative in the denominator, whereas a binomial, it'd have to be trickier, and don't worry, that's going to be my next example. So this is negative of x to the third over x to the fourth plus 1, right? And that is f of x, right? So this is negative of f of x, and that's this. That's odd. Okay, so, and my next example, I got that kind of there. Another bonus. So you can say to yourself how lucky you are to get some bonuses here, right? Is I'll make this x to the second up here. I'll make this, I didn't mean to make it negative, but I wanted to make this x to the third plus 1, okay? And I just want to show you if you plug in here. So remember parentheses, squared, cubed, negative x, negative x. So when the dust clears here, I guess I wasn't writing that on the others, and so I'm not going to write it there either. So this is going to be x squared in the numerator, and in the denominator negative x to the third plus 1. And you might say, well, can't you use that same story and I have like the negative b? But I really don't, because that negative is only going on the x. So I can write it like this, x squared, and I can factor out a negative, and that'd be x cubed, but then it would be minus 1. So I could do that, right? So you can distribute back the negative. Negative times x cubed is negative x cubed, and negative times that negative there is a positive, right? That would be great. And then, because now this negative is going with the whole denominator, I can say that's the b, right? And I can put the negative out to the side. I'm almost out of room here, so I'm going to put arrow up here. So this would be x squared over, the negatives coming out to the side, and then I'd have x cubed minus 1. But that is not equal, where was it? Here it is. That is not equal to this, right? Because it's x cubed minus 1, not x cubed plus 1. And so this I won't be able to write back with f of x, right? It won't be the opposite of f of x, and so this is neither. Okay, my lovely calculus doing friends, and so that is the notes I have for you for section 1.1 in 3 parts, and so we'll see you in the next video. Bye-bye.